Hi, good day everyone. First of all, I would like to thanks to the committee and organizer Seminar Applications of Physics in Mechanical and Materials Engineering 2024 for having me as invited speaker for today. My name is Farhana Zainal from Department of Materials, Faculty of Chemical Engineering and Technology, University Malaysia Perlis, Malaysia. So today I would like to share my research work. The title is The Effect of Primer Layer and Curing Method on Geopolymer Paste Coating Properties. So this is the overview for my presentation today. I will start with the introduction, the problem statement, the objective, the literature review, methodology, results and discussion, conclusion, and acknowledgement. For introduction, geopolymer technology has emerged as a sustainable and cost-effective solution with numerous advantages over traditional cement-based materials. And geopolymer coatings also have gained the attention for their superior performance and environmental benefits in various applications such as petrochemical facilities, industrial setting, improved resistance to chemical attack, and higher thermal stability. So, this is the problem statement. Master pipeline, as we can see from the figures, used for transporting liquids and gases are susceptible to corrosion when exposed to the surrounding environment. Corrosion compromises the pipeline structural integrity, wall thickness, and overall strength. Proper corrosion protection measures are crucial to ensure the longevity and reliability of these pipelines. Primer coats play a vital role in the corrosion protection system for my steel pipelines. It is very crucial to comprehend how various primer coats affect the effectiveness and durability of geopolymer coatings in providing corrosion protection. So the choice of primer coat can influence the adhesion strength, the corrosion resistance, and overall performance of the geopolymer coating on my steel pipelines. So these are objective for my research work. The first one, I would like to investigate the characteristic of raw materials to assess their suitability for geopolymer coating on my steel pipelines. The second one, to determine the effect of geopolymer coating on epoxy metal primer and self-etch primer on my steel pipeline via various curing conditions. And the last one is to study the geopolymer coatings, microstructural properties, phase composition, and adhesion strength on my steel pipelines. This is the literature review for my research work. So compared to the other pipelines such as galvanized iron pipelines, my steel pipelines are much more susceptible to rust and corrosion. To lessen the likelihood of my steel pipelines developing rust and corrosion, a protective coating is required on their outside surface such as geopolymer coating. And geopolymer could be a less expensive alternative to ordinary Portland cements. So it is considered an environmentally restorative materials due to its low embodied energy, as is a byproduct and required less energy for manufacturing and transportation compared to other construction materials like OPC, Portland cement. And the primary coatings are very critical in enhancing the adhesion strength between geopolymer paste layers and my steel pipelines. And geopolymer coatings are commonly applied to my steel pipelines to protect against corrosion and extend their service life. However, the addition between the geopolymer coating and the steel substrate is a key factor in determining the overall performance and durability of the coating system. And one limitation is their sensitivity to the environmental conditions during the application. So the presence of moisture or humidity can affect the reaction and formation of the protective phosphate layer, potentially compromising the adhesion and corrosion resistant properties. For the methodology, this study explore the impact of primer coats on the properties of geopolymer coating itself used on mild steel pipelines. So the goal is to find the most practical combination of primer coats and geopolymer paste to enhance the corrosion protection. The findings will contribute to developing effective corrosion resistant solutions, prolong the service life of pipelines, and reducing maintenance costs. So, this research aligns with advancing sustainable infrastructure, developing by minimizing the environmental impact of corrosion prevention strategies. So, this is the sample preparation. So, geopolymer paste was prepared using fly ash class C as a base material and mixed with the alkaline activators, which is the sodium hydroxide solution and sodium silicate solution. And then my steel pipelines were divided into three sets. One is without primer, one with epoxy metal primer, and last one with self-etch primer. And then the samples were then divided into two sets with one set cured at ambient temperature and the other set cured at 60 degrees Celsius in an oven for 2 hours. And then after curing process, the samples were placed under ambient conditions for 28 days. So after 28 days, the testing for phase analysis, morphology analysis, and addition strength tank analysis were involved. For phase analysis, phase composition and crystalline structure of the raw material and geopolymer paste were determined using XRD analysis. For morphology, the physical structure and microstructural properties of the raw material and geopolymer paste were examined by using scanning electron microscope SEM. And the last one, addition strength test, the bond strength between different materials or layer was evaluated through addition strength testing using standard ASTM D4541. So this is the results and discussion for phase analysis. As we can see, the XRD analysis, we will run the XRD analysis of fly ash, samples cured at ambient temperature, and sample cured at 60 degrees Celsius in oven for 2 hours. Okay, for the B and C, the blue color is self-etch primer, the red color is epoxy primer, and the black color is without primer. Okay, from the XRD analysis, we will confirm the presence of quartz, magnetite, aluminum oxide, and mullite in the geopolymer coating. So the self-etch primer coated sample show the formation of iron oxide particles through the chemical precipitation. Then this is the morphology analysis. As we can see from the morphology analysis, uh, A is the fly ash samples, B is without primer, C is with self-etch primer, D is with epoxy metal primer, E is without primer, F is with epoxy metal primer cured at 60 degree Celsius in oven for 2 hours. So from the figure, the microstructure analysis of the geopolymer coatings on mine steel pipeline as observed in the SAM micrograph provide valuable insights into their characteristics. So similarly, the sample with epoxy metal primer also exhibits a combination of unreacted fly ash and geopolymer paste, indicating a more cohesive structure compared to the sample without primer. As we can as we can see, for B figures, for C, for D, for E, there are unreacted fly ash in these SEM results. But in the SEM micrograph or sample with self-etched primer cured at 60 degrees Celsius in oven for 2 hours. So the SEM analysis demonstrate that multi pipelines that coated with self-etched primer greatly influences the microstructure of geopolymer coatings. So it reduces the presence of unreacted fly ash, promotes the formation of dense gel matrices, and enhances the binding of quartz powder. So these improvements suggest that geopolymer coatings cured at elevated temperature have the potential to exhibit superior properties in terms of adhesions. So in terms of durability and also corrosion resistant compared to those cured at ambient temperature. So this is the best compared the others. So the last one is the addition strength test. From the graph here, this is the addition strength result of geopolymer coating on my steel pipeline with